Energy is necessary for our life. In the modern world, humans consume more and more energy for all their activities, causing various emissions that have a significant impact on our planet. In Europe alone, buildings consume a whopping 40% of all energy, mainly for heating and cooling, and they are responsible for 36% of Europe's CO2 emissions, which have a negative impact on pollution, general health, and global warming. Furthermore, 75% of these buildings are not energy efficient, and 85 to 95% of them are expected to still be standing in 2050, also leading to significant operating energy costs. Energy poverty is a pressing problem worldwide. Even in Europe, more than 34 million people cannot afford to pay their energy bills and live in unhealthy, uncomfortable conditions. At Knauf Insulation, we believe our buildings should be fundamentally energy efficient and provide the much-needed thermal comfort their occupants deserve. Let us take a look at how outdoor temperatures challenge our lives and how we can help save energy, protect the environment, and ensure healthy and comfortable buildings. Depending on geographic location, lower outdoor temperatures in the winter force many buildings to turn on their heating systems to keep people warm. Since most buildings are older, lack proper thermal insulation, and are energy inefficient by today's minimum standards, much of the heating energy escapes through the building envelope and is wasted. In such buildings, unwanted drafts and radiating cold from uninsulated wall, floor, and roof surfaces are common. This not only leads to excessive heating, but also low thermal comfort, making us feel stressed, annoyed, distracted, or even sick. More importantly, excessive cold or hot indoor environments are unhealthy, especially for the elderly, sick, or infirm during harsh winters or severe heat waves. Over the last decade, a shocking 250,000 elderly people have died from cold weather in the UK alone. That's one elderly person every 7 minutes. At the root of this problem are cold, poorly insulated homes. On the other hand, during high-temperature summers, many buildings tend to dangerously overheat. When it's too hot, we can feel sleepy, tired, and unfocused, which in turn leads to low thermal comfort. This is particularly important if occupants are elderly, very young, or suffer from cardiac, kidney, or respiratory diseases. In UK, for example, 1 in 5 homes already overheat. In North America, more people are killed by heat waves than any other natural disaster, according to the National Weather Service. As temperatures rise, demand for air conditioning is also expected to triple by 2050, leading to higher energy costs and emissions. Summer heat waves are becoming more frequent due to climate change. If we want to future-proof our world, it is imperative that we rethink how we design our buildings. Why does this happen? Physically, heat always moves from areas of high temperature to those of lower temperature. Therefore, when the outside temperatures are cold in the winter, heat inside the building will try to escape through the major structural elements such as walls, windows, roof and floor, including through ventilation and leakage losses, as well as through thermal bridges. However, this also occurs in summer, when hot air enters the building from the outside, resulting in a warmer indoor environment. This heat flow occurs through conduction, convection, and radiation. Conduction is the transfer of heat through a material or from one material to another by direct contact, for example, through the exterior wall of a building. Convection occurs in gases and liquids, such as the heat that rises from radiators in houses. Radiation is the transfer of infrared radiant energy from a hot surface to a cold surface through air or vacuum. An example is the radiant heat we receive from the sun or a heated fireplace. In a typical uninsulated house, about half of the heat generated inside is lost through the walls and roof, making them two largest causes of heat loss. Thermal bridges are localized cold surfaces in buildings with additional heat loss usually due to joints or penetrations of different building materials and elements. These places usually have such a low temperature that the warm indoor air starts to condense there, attracting unwanted mold and other microorganisms. The common factor that allows excessive cooling or overheating of buildings with high energy consumption and low thermal comfort is a building envelope with insufficient thermal performance. How can this be resolved? The first and most effective step to address these problems is to improve the energy efficiency of buildings, especially building envelopes, by installing sufficient and appropriate thermal insulation. The primary purpose of thermal insulation is to limit either heat loss or heat gain through a building exterior envelope, as it has low thermal conductivity. Thermal insulation provides many vital benefits. It plays a huge part in keeping the temperature inside the building constant throughout the year by keeping the heat out in summer and protecting it from the cold in winter. A well-insulated building requires far less heating or cooling and is therefore more energy efficient in the long term, saving money and reducing emissions at the same time. Continuously and correctly installed thermal insulation is also the best long-term solution to ensure overall thermal comfort, as it improves both the ambient temperature and the radiant temperature of the interior surfaces. We perform better and feel healthier when we are comfortable. Large-scale, deep renovations of buildings and energy-efficient new buildings are excellent tools in the fight against energy poverty as well as climate change, two major interconnected challenges. Thermal resistance is the most important material property that should be defined when specifying insulation materials. It is determined by the thickness of the insulation and the thermal conductivity of the material. In general, the greater the temperature difference between the inside and outside of a building, the greater the heat flow and the thicker the insulation layer must be to reduce heat flow. There is a very wide range of insulation materials on the market. Thermal insulation of buildings has to be very carefully chosen and detailed to ensure that it offers the best synergy with acoustic and also fire performance. Due to its nature, mineral wool insulation provides the best combination of thermal, fire safety and acoustic performance. It is also easier to install as the fibrous structure of the material fills the space, meaning that any imperfections in installations are negated and therefore give a better real performance. Mineral wool insulation slows heat transfer by convection, conduction and radiation thanks to its interwoven structure. The inside of the material is made of millions of tiny air pockets that trap any heat or cold that tries to pass through, making it one of the most efficient materials to insulate any building. To maximize the performance of insulation, it is important to also ensure that the building envelope is airtight. This means sealing uncontrolled leaks of heated air through the building envelope, such as gaps at window frames. On the outside, we can use weather membranes to ensure that wind and water cannot penetrate, but water vapor can escape to avoid the risk of condensation. On the inside of the building envelope, the air sealing function of the membrane is often combined with vapor control function. Building regulations set out minimum standards for the thermal performance of the building thermal envelope, which means roof, wall, floor, windows and doors, by reference to limiting U values and total energy consumption of the building based on climate conditions. However, when it comes to insulation installed for the lifetime of a building, it is advisable to far exceed the minimum standards, as a well-insulated building envelope brings many long-term benefits and ensures a future-proof building design, resilient to future changes in building codes and climate changes. A well-insulated building will passively provide high thermal performance, comfort and energy efficiency without the need for maintenance. Regulation must be the driver to accelerate and mainstream energy retrofits of the existing, highly inefficient building stock around the world. A good example is the European commitment to at least double the renovation rate over the next 10 years and renovate 35 million buildings by 2030. In addition, from the beginning of 2021, every new building in Europe must be nearly zero energy building. Knauf Insulation offers a wide range of expertise and high-quality solutions that can be installed both externally and internally to improve the energy efficiency and thermal comfort of any type of building. We offer products that provide outstanding thermal performance, ranging from rock mineral wool and glass mineral wool to wood wool, along with our home seal vapor control and air tightness solutions. In addition to insulation materials, our Urbanscape green roof and wall solutions also cool buildings and lower urban temperatures through the evaporation of stored rainwater. Knauf Insulation mineral wool is so versatile that it can be used in almost every part of building, from roof to floors, technical installations and even domestic appliances such as ovens. Our mineral wool insulation solutions also provide excellent fire protection and acoustic properties. At Knauf Insulation, we believe our role is not only to produce energy-saving products, but also scientifically test how those products perform once they are installed. We work with leading building scientists, architects, policymakers, installers and the building chain to understand how to deliver buildings that actually perform as intended, with great attention to good workmanship. This is why we built experience and training centers where we provide the highest level of knowledge and practical training to key stakeholders in the construction industry. We do our best to create more comfortable, energy efficient and better buildings for a better world.